Good morning, all of you.
Good morning, sir.
Good morning, sir.
What was the last thing we covered in the previous class?
Sir, you had to do some linear angle.
To do?
So
relation between solid angle and linear angle.
We derived the relation between solid angle and linear angle.
Okay. Now, 2 minutes, let us remind ourselves of what we have dealt with in Gauss dot. Now, we said closed integral E dot ds will be the flux through a closed surface. It will be equal to Q by epsilon naught. This is the first point. Second point, Q must be charge enclosed inside the Gaussian surface. Agreed?
Yes, sir.
Third point, we said field is due to all charges within the vicinity. Both inside and outside the Gaussian surface. Both inside and outside the Gaussian surface. Right? We have given justifications for this. We showed why it happens. Third, we also learned how to assume Gaussian surface. How to assume a Gaussian surface. Assume a Gaussian surface. Till here we have learned. Fifth point, we said relation between solid angle and linear angle is 2 pi into 1 minus cos theta. So far, so good. Summarize these 5 points. We'll go ahead.
Sir, in the third point, why would it be because of all the charges?
Iska, we have given justification. If you remember, we have taken an infinite long wire. I took the field here. field E and ds. Closed integral E dot ds में I took lambda L by epsilon naught. That means charged and closed inside. But field I was getting as 2k lambda by r. It was the field because of all the charges within the vicinity. You got this by integrating from minus to plus infinity.
Yes, sir.
By this procedure also you are getting the same answer. Implies field is because of all the charges.
Right, sir. Understood.
And in the derivation, where did you accommodate that field is because of all the charges? You took field parallel to ds all throughout the length.
Yes, sir.
Yes, sir.
Tell me when I can rub the board.
Yes, sir.
If there is a charge outside the Gaussian surface, it will contribute to the field but not the flux. If there is charge outside the Gaussian surface, it will contribute to the field but not the flux. Is everybody clear about it?
Yes, sir.
Now listen. There are a specific set of problems which we have to follow this sequence. First example that I take, you have a square plane and a charge q. This distance is a by 2, this distance is a. This distance is a by 2, this distance is a. Square plate sides are in. They are asking you flux through the square plate. Flux through square plate.
AQ by R square into A square.
One second. No. Listen. Traditionally, what am I supposed to do? I have a charge q here. Right? I have a charge q here. Because of the charge q, I will take a strip here and I'll take the field along that strip to be integrated to get the flux through that strip. That flux I will have to integrate from here till here to get the total flux through this plate. I'll draw the diagram. 1 second, listen. You have a charge q at a distance of a by 2. You have a charge q at a distance of a by 2. Now take an element here. Because of this, the field will be like this. ds will be like this. ds will be perpendicular to the element. I'll have to integrate from here till here to get the flux through this strip. That I will have to integrate from here till here. Firstly, that is the traditional way you solve that. That means you are integrating twice. They are called surface integrals. You integrate once, it will be line integral, which is there in your syllabus. Surface integrals will be taught in engineering first year. Volume integrals will be taught then only. Are you trying to tell me that this problem is out of your syllabus because it is surface integrals? This procedure will be out of your syllabus. You will have to integrate from here till here once. That I will have to integrate from here till here. Though you will draw even this diagram. These are called surface integrals. These are called volume integrals. This is called line integral. Now, we don't have surface integrals in the syllabus, so we will have to think of an alternative means, which will be Gauss. How are you going to think of it? Now observe this carefully. This is a cube. Of edge length A, and I have charge Q at the center. This is a cube of edge length A, and I have charge Q at the center. Can you tell me what will be the flux through whole of the cube? Flux through whole of cube.
Q by epsilon naught.
Q by epsilon naught.
Q by epsilon naught. Because the charge is at the center of the cube, flux through each phase will be Q by 6 epsilon naught. Now this privilege is extended only for a system where Q is at the center of the cube. What if it were not at the center of the cube? I cannot solve this problem this way. Do you have an alternative? No other alternative. Have to go by this system. So paper setter will give you something in which you should be able to think of an alternative using Gauss law. Is this point clear? That means if this charge was not at the center, then the first line is perfectly right. Second will not be correct. Only the first will be correct. So paper setter will take care of the system that you are able to answer the question. So he will design the question in that way only. What are all the designs? I will keep you informed. Take it down to here.
So divided by 6 because of symmetry, right?
Right. Symmetry could be availed only because the charge is at the center.
Sir,
One
but
second, wait. 1 second, wait.
sir, but we can place the charge anywhere inside, and we can say through the whole Q it will still be Q by epsilon naught only, right?
That will be 100% right always. This will not work out always. Can I rub the board?
Yes, sir.
sir.
Suppose I have a cube here. and I have a charge Q at one corner of the cube. Charge Q at one corner of the cube. I take this 0, 1, 2, 3, 4, 5, 6, 7. I have charge Q at one corner of the cube. Think carefully. Solid state chemistry did they introduce cubic, orthogonal, rhombohedral?
Solid state is not
Solid
there.
state,
Solid state has not started yet.
Okay. First write down the question. Charge Q is at this corner. Question as is find the flux through each face of the cube. Find flux through each face.
So we have to do surface integral.
No. There is an alternate.
Q by 8 epsilon.
There is alternative. 1 second, I'll keep you people on mute. Think for a minute, I'll give you the hint. I'll explain. I was searching for an animation which I didn't get, but it's okay. Listen, I'll explain. Am I on mute?
No, sir.
Okay. Now listen. Basically, what part of this charge will come inside this? What part of the charge will come inside this? This corner is shared by 8 cubes. This corner is shared by 8 cubes. Do you agree with that?
Yes, sir. So one eighth.
4 on one floor, 4 on the above. This corner is shared by 1 cube behind, 2 cubes to the left on the same floor. And then above there are 4. This corner is shared by 8 cubes. So flux through whole of this cube is q by 8 by epsilon naught. This is q by 8 epsilon naught. First step, is it clear to all?
Yes, sir.
Now watch out for the next step. If you take this charge, field lines from this charge will go parallel to 0, 1, 2, 3. Flux through 0, 1, 2, 3 will be equal to flux through 0, 4, 7, 3. 4, 7, 3. Flux through 0, 1, 5, 4. All 3 faces which are touching this particular corner will have 0 flux, because the field lines will go parallel to that.
So
All 3 faces, observe this 0, 1, 5, 4. Field lines from this charge will go parallel to this face, and area vector will be perpendicular this way. Are you able to visualize this? Field lines from here will go parallel to this face. Area vector will be perpendicular to that face. So flux through 0, 1, 2, 3, 0, 1, 5, 4, 0, 4, 7, 3 will be 0. This point, is it clear to all?
yes,
Yes,
sir.
sir.
All of you able to visualize that?
Yes, sir.
Or I'll put it this way. If you
Constant will be 0.
see this corner, if you people can see this corner, observe this. Observe this. Are you able to see this corner?
Yes, sir.
Field lines from this corner will go parallel to this wall. Agree?
Yes, sir.
They'll go parallel to the ceiling
Yes, sir.
Yes.
and they'll go parallel to this wall.
Yes, sir.
So this corner, whichever you take, this corner or this corner, field lines will go parallel to this face. They'll go parallel to this face and they'll go parallel to this face.
Yes, sir.
Area vector is perpendicular to that. So flux through this face and this face will be 0. Right?
Right, sir.
Yes, sir.
Now then comes flux through 4, 5, 6, 7. 4, 5, 6, 7. Flux through 2, 6, 7, 3. 2, 6, 7, 3. And flux through 1, 5, 6, 2. Flux through 4, 5, 6, 7. Flux through 2, 6, 7, 3. And flux through 1, 5, 6, 2. All of them will be equal by symmetry. Hence, they will share 1/3 of this q by 24 epsilon naught. If you are taking this corner, flux through that face and the bottom. 4, 5, 6, 7. 1, 5, 6, 2. And 2, 6, 7, 3. By symmetry, they will be equal. Hence, there will be 1/3 of this, each face of them. Is this problem now clear to all?
Yes,
Yes,
sir.
sir.
All these set of problems, do we have to think from the direction of Gauss law, q by epsilon naught, and do the back calculation for each face? Yes. Because surface integrals are not there in your syllabus. The other way you can think about this is, consider a cube of side 2a with this at the center. Consider a cube of side 2a with this at the center. Are you getting my point?
Yes, sir.
Yes, sir.
So there will be literally 8 cubes. This is the center. One cube is here, one cube is here. 2 cubes behind me. Upper 8 cubes. So total a cube of side 2a and I am at the center. So through flux through each of the face will be q by 8 epsilon. Each of the cube will be q by 8 epsilon naught.
Yes, sir.
Right? It is the same thing with a slightly different.
Q by 6, right?
Pardon?
Q by 6, right?
Q by 8.
Q by 8.
Sir, Q by 6.
There'll be 8 cubes total.
Why it is correct?
4 on one floor, 4 on the floor above. This will be the center. So 8 cubes. Through each face, it will turn out to be q by 8 epsilon naught. To each q by 8.
Sir,
Ah,
phi through 0, 1, 2, 3, 0, 4, 7, 3, 0 कैसे हुआ? Can you explain once more?
field lines are going parallel to that surface.
अच्छा, okay.
So area will be perpendicular. So dot product will become 0.
Hmm.
Field lines will go parallel to that particular surface from this charge. Charge is on that face, one
Okay.
corner of the face.
Hmm.
Like telling you, I take a square plate and I've got charge here. So field lines will go parallel to this plate.
Yes.
This is a place. If I have got charge at the corner, field lines will go parallel to this face, right?
Yes, sir.
Area vector is perpendicular. What will happen to the flux?
Cos 90 0. Dot product में cos 90 आ जाएगा. Okay.
So you got flux on 4, 5, 6, 7, 2, 6, 7, 3 and 1, 5, 6, 2 equal because of symmetry.
Right.
Okay, sir.
Can we find the second part as imagining 2, 3, 6, 7, 2, 3, 6, 7 is 1/4 of the face of the larger cube with Q at the center? Yes. Yes, somebody from the other side with this. Have you people taken this down?
Yes, sir.
Now listen, some people in between were saying q by 6 epsilon naught. Right? What they were assuming, I will tell you. Have a look at it. They'll consider this as the center and this is 2a, this is 2a, this is 2a, this is 2a. This is one phase of the cube of edge 2a. Are you able to visualize this?
Yes, sir.
This is one phase of a cube of edge 2a. And this q is at the center. Now, what is the flux through this phase? Q by 6 epsilon naught. We have just dealt before this.
Yes, sir.
All of you, yes or no?
Yes, sir.
Yes, sir.
Now, this phase is divided into 4 parts. So, what will be the flux through this phase?
Q by 24 epsilon naught.
24.
Is the logic clear? They have a
Yeah.
cube of side 2e with this at the center. So, if this is the center, what will be the flux through whole of this plane? It's q by 6 epsilon naught. There are 6 phases. So 1/4 of that will be the flux through this. That turns out to be q by 24 epsilon naught.
But sir, will it be equal in all the 4 halves?
All the 4 equal by symmetry. This is at the center, right? For this plane, this is at the median. Q is at the median. Suppose I take a cube like this. and I keep charge Q here, I split this space into 4. 1, 2, 3, 4. Flux through all 4 of them will be equal by symmetry.
Understood, sir. Right.
This is the second way of looking at it. Clear up the board.
Yes, sir.
We will take this one more step ahead. Now cube, it was easy by symmetry to play with. If I have got a charge Q here and Q here, and I have a circular disk at a distance of x of radius r, what will be the flux through this disk? This will be the way the field lines go. Both are Q and Q, right?
Yes, sir.
How will the field lines go? We will go this way. Here the field is 0. So what will be the flux through this surface?
0.
0.
So what
Right.
in the center it will be 0, right?
All throughout the field lines will turn tangential, right? At this point, it will produce a field.
Yes,
Which
sir,
will
got
come
it.
this way. The horizontal components cancel out. Vertical components add up. So
It will
here
act as
the field will be upwards. Area will be this way. So dot product will become 0.
0. It will act as a mirror.
Right. Now what if you remove one of the charge? There will be flux through this. 1 second, wait, there is some call coming. First take this down and explain what to do when Q is removed. Can I have the board?
Yes, sir.
Yes, sir.
Now, what if I have got only one charge Q and I ask you the flux through this particular phase at a distance of x of radius r. You are asking me flux through the circular disk. Now listen. Keeping this at the center, can I draw a spherical surface like this?
Yes, sir.
Assume I have drawn a good spherical surface. Can I claim that flux through this surface and the circular plate will be the same as the solid angle subtended is the same?
Yes, sir.
Yes, sir.
Yes,
Flux
sir.
through this surface and the circular plate will be the same as the solid angle subtended is the same.
Yes, sir.
So for 4 pi solid angle, flux is q by epsilon naught. Who told you this?
Gauss.
For this solid angle, what will be the flux? Q by 4 pi epsilon naught into the solid angle. How much is this solid angle? It will be 2 pi
Pi
into
1
1
minus.
minus cos theta. Q by 2 epsilon naught into 1 minus. What is cos theta? X divided by root over of r square plus x square. All that we have done is we drew a spherical surface this way. Flux through the spherical surface and this particular disk will be the same. Right? Because both subtend the same solid angle. So unitary method for 4 pi solid angle flux is q by epsilon naught. For this solid angle, how much is the flux? Substitute the value of the solid angle, you get the flux through this. None of these problems you are doing surface integral to find out the flux. If you are forced to calculate using surface integral, implies you are on the wrong track. You are missing on something. All these problems you will take Gauss law and do the back calculation. Take it down till here.
Sir, we don't have to remember this result, right?
But you'll remember the procedure and okay with it. Those steps may aa jayenge, so it is not too much of time consuming. You should know the procedure. Because the procedure will be used in many places. For 4 pi, this is the flux. For this solid angle, what will be the flux? Unitary method. Value of solid angle, you should be able to calculate.
Done, sir.
I have now q and minus q. What will be the flux through this particular surface? Q and minus q. what will be the flux through that circular disk?
Two q by two epsilon naught. Q by epsilon naught bracket 1 minus x square by r square plus x square.
2 times full of this. Two times this. Why?
So that twice the field lines passing through in the same
Yes,
direction.
sir.
I'll make you look at it in slightly different way. Very slightly.
So we can also imagine like q is giving an acceleration kind of stuff, and then small q is attracting more.
Something very new is being told. Very silly is being told. Dhyan se suno. Before this problem, what problem did you do?
Both are positive charges.
When both are positive charges, what is the flux through this space?
0.
You mean to say, if I add a positive charge here and positive charge q here, the flux through this will not change. Yes or no?
Yes.
Yes, sir.
If I add a positive charge here and positive charge here, flux through this will not change.
Yes, sir.
Add, your job is done. I put a plus q here, minus q plus q became 0. Here it became 2q. I multiply it with 2. Oh. Yes or no?
Sir, can you please repeat
Yes,
that?
sir.
When I have q and q here, what will be the flux through this disk?
0.
So I can add q and q here and the flux through this will not change. I add a q here, I add a q here. Flux will not change. I added them. This became 0, this became 2q. I multiplied this with 2.
Right, sir. Just like relative q.
Left side charge will become 2q. So instead of q, you have got 2q. Flux will be 2 times that. In for a circle, I have q and q here. What will be the flux through this? 0. So if I have q and q at equal distances, flux through the disk will be 0. So q and q at equal distances will not disturb the flux through this. Add q and q there. I am more than happy to give you 2 times the answer.
So, sir, it will be equivalent to a charge of 2q.
Right? 2q here and that is 0. So this will be 2 times. Hemispherical bowl of radius r. There is a charge q kept just outside the surface of the hemisphere. Just outside. Find flux through the hemisphere.
0.
No. Think carefully and solve. Don't be in.
So it's outside, so it will be 0 only.
See the question again. If I say anything, that will become the hint for the problem. Hence, I am not speaking. Think carefully. एक ही step में answer आ जाएगा. That's the best hint I can give you. And answer is not 0. See the question properly.
So, got it.
flux total is 0. That will be flux through hemisphere less flux through the circular part. Flux through whole of the surface will be 0. Flux through the hemisphere plus flux through the circular part. Do you agree with this?
Yes, sir.
I am not in a position to calculate this, but I know the answer for this. This and this I know. Will I get the flux through the hemisphere?
Yes, sir.
Through the circular part के लिए here R is equal to X Q by 2 epsilon naught into 1 minus cos theta Q by 2 epsilon naught into 1 minus X is R divided by R root 2 Q by 2 epsilon naught into 1 minus 1 by root 2 is the flux through the circular part less flux through the hemisphere should be 0. Will I be able to calculate the flux through the hemisphere?
Yes, sir. So can't we say that on the hemisphere it will be 0 or 1, there will be circular part which is a part of the hemisphere?
Say that again.
I interpreted it like this, that if through the hemispherical curved part the flux will be 0, and through the circular part it will be some flux which will be equals to the flux on the entire surface.
क्या बोल रहे हो मुझे कंफ्यूज कर रहे हो through the hemisphere and the circular part both put together it is 0.
Okay, because it's a closed
Go
part.
through the hemisphere, find out the flux through the circular path. Then you may say, when I take this to the left, I'll get negative. Yes, you'll get negative flux because area and field are in opposite direction. Area will be outwards, field will be downwards. Angle between them will be greater than 90. Tell me when I can rub the board.
Done, sir.
At a distance of x from the center, you have a charge q. Find the flux through the curved surface area of the cone. Flux through curved surface area of cone.
So flux would be 0 for any closed body, right?
Yes, if the charge inside is zero.
If the charge inside is.
For any closed body, if the charge enclosed inside is 0, the flux will be 0.
Done, sir.
The concept is the same here as well. Flux through the circular part plus flux through the curved surface, both put together should be 0. You are asking me flux through this. I can calculate the flux through this. This is q by 2 epsilon naught into 1 minus x by root over of r square plus x square. Take this to the right, I will get the answer for this. Now, ironically, this quantity will have a negative sign. Why?
Opposite direction.
This phase, you are taking area this way and field in the opposite direction. Angle between them all throughout this outer phase. If I have got, I am taking this upper phase. So here I will have area this way. I will have field this way. Area and field make an angle greater than 90. So flux through the outer surface of the circular plate. ध्यान से देखो, if there is a charge q here, through this phase, flux will be negative. If there is a charge q here, through this phase, flux will be negative. Right? This is area.
Yes.
Field lines will be this way. Angle between E and A will be greater than 90. Through the lower phase, flux will be positive. If I take a plate here and I have charge here, through the upper phase, flux is negative. Through the lower phase, flux is positive. Do you get this difference?
Yes, sir.
So this negative, when I take it to the right, flux through the curved surface, I will get it as positive. Listen to this typical problem from Proto. This is Q and this is minus Q. This is Q and this is minus Q. Agreed? Proto is asking you, if there is an electric line of force here at an angle of alpha and this at an angle of beta, find the relation between alpha and beta. Find the relation between alpha and beta. Think for a minute, I'll explain. This problem is a typical problem of its own. There will not be another problem like this. Sorry, make one correction. This is Q1, this is Q2. This is Q1, this is Q2. Both are not the same. If they are the same, alpha is equal to beta. Both are not the same.
Q1 sin alpha equal to Q2 sin alpha sin beta.
Q1,
Sin alpha equal to Q2 sin beta.
no. But you are a bit close, probably.
I just made a guess.
Then you are wrong. तो guess करोगे बताओगे तो मैं हाँ बोल दूँ सही आंसर बोलोगे तो भी गलत बोल no guess work solve करो Q2 by Q1 beta no Chinmay no. The problem is very unique and typical of its type. Think for a minute. When I tell you the answer, you'll admire.
So that's a field line, right? From Q1 to Q2.
This is a field line.
Right.
There will be a field line even like this. Quite obviously, this will also be a field line. Relation between alpha and beta is asked. Somebody typed the correct answer. Is 1 minus cos beta by 1 minus cos alpha is right. Now listen. This is one field line and this is one field line. In between these two field lines, there will never be a field line which comes here and stops. If it starts from here, it has to go into Q. There are two alternatives which can happen. Listen carefully. You may tell me there is a field line which comes till here and it will go out this way. Not possible. Why? Field lines don't intersect. So this option is eliminated. This point, is it clear to all?
Yes, sir.
Second option, the field line comes till here and stops. Not possible.
Complete loop.
Hence, this field line starting from here has got to go into minus Q2. If there is a field line between this and this, it must be entering into minus Q2. I can have a field line outside which will not pass through minus Q2. This we have seen. Yes or no?
Yes, sir.
Yes, sir.
Yes,
This
sir.
I can have not passing through minus Q2, but if I tell you this line is going into minus Q2, any field line in between must be entering into minus Q2. So
Right.
far, so good. That means the flux between this angle and this angle must be the same. Flux generated by Q1 between these two field lines must be equal to the flux entering into Q2 between these two field lines. Because there cannot be a line of force which comes and goes out or stops here. It has to enter into minus Q2.
So,
Because this line is entering in and this line is entering in. Now what will be the flux here? For 4 pi solid angle, flux is Q1 by epsilon naught. For this solid angle, Q1 by 4 pi epsilon naught into the flux. Q1 by 4 pi epsilon naught into the flux will be 2 pi into the solid angle will be 2 pi into 1 minus cos alpha. This will be the flux generated between this line and this line effectively. Half of this will be between these two lines. Because
so
this is the solid angle.
shouldn't it be cos 2 alpha?
Alpha, see the angle between this is a desk, this is Q, this is theta. 2 pi into 1 minus cos theta will be this solid angle,
Right, sir. Right.
right? So it is cos alpha will be for whole of this solid angle between these two. Half of that will technically be the flux between these two lines. What will be the flux entering into minus Q2? 4 pi solid angle will be minus Q2 by epsilon naught entering, right? For this solid angle, it will be Q2 by 4 pi epsilon naught into this. Q2 by 4 pi epsilon naught into 2 pi into 1 minus cos beta. What is this angle beta? So can I equate both of them?
Yes, sir.
Flux generated between these two lines must be entering between these two lines. When I equate both of them, Q1 by this will become 2. This is Q1 by 2 epsilon naught 2 sine square alpha by 2. This will be Q2 by 2 epsilon naught into 2 sine square beta by 2. Yes or no?
Yes, sir.
Q1 by epsilon naught sine square alpha by 2 is Q2 by epsilon naught sine square beta by 2. Q1 by Q2 will be sine square beta by 2 upon sine square alpha by 2. A typical problem from Krotov.
So we'll just take the magnitude of Q2, not the sign.
The sign only tells us that the field lines are entering into Q. Here the field lines are going out of Q. So the negative sign tells me that the field lines are entering. And here I am not carrying a negative sign because when I write sin beta by 2 and sin alpha by 2, I have to put a square root.
Right.
So that will make it imaginary. So we don't carry the negative sign there. What happens if it is like this? Listen. If there is a field line outside this which goes this way, that doesn't affect my problem. That can be a field line which goes this way. We have no problem. Between this line and this line, there will never be a field line which goes this way. If this line is entering in, any line between these two must enter into Q.
So, but then the solid angle which will create at beta, which will be tangential at that point. So it will, the outer line will also pass through that.
I didn't get you.
So when we create a solid angle at beta,
Okay.
so like you will just create like two tangents over there. So sir, if you extend the upper tangent, even the upper line which is not passing through Q2 will be under that solid angle, right?
हो ही नहीं सकता. Now you extend this to anything. This solid angle. If that were true, you mean to say there can be a field line entering like this?
Yes, sir.
It may. I have no problem with that. Then it should be starting from Q. Right? So flux will be the same. How much is the flux you are not worried about? Flux will be the same. If it is entering here into this solid angle, it must be entering even from here. I can have another line about this. You mean to say this can happen? There can be another line. I have no problem with it. My requirement is this solid angle and this solid angle will have the same flux. I am worried only about the line in between these. Outside may enter, may not enter. I don't care. That can be a different line.
But the one that does not enter will not pass through that same solid angle, right?
Naturally.
Okay, sir.
We go this way. Right?
Yes, sir.
Now observe one thing here. We have dealt with ring. We have dealt with an infinite long wire. We have dealt with hollow sphere. We have dealt with solid sphere. But we didn't deal with a disk. Disk ka field and potential you didn't calculate. We kept it pending till here. Gravitation you should have done now you are using calculus. There is a reason why we kept it pending till here. There will be a very innovative way of solving this using solid angle. Till we introduced solid angle, we kept this pending for this reason. Have a look at this first of all. This is a disk. This is a disk. Right? Now for this disk, I will try to calculate sigma is the charge density. Charge density. I want the potential at a distance of x. I want the potential at a distance of x.
So non-conducting.
Temporarily charge only on one surface, one side. The other side I am not taking. So don't worry about conducting, non-conducting. I will come to that in the next class. Shielding pada. There is only one shield. That means you have charge only on one side. This side. This side you have no charge. Consider an elemental ring of distance smaller. What will be the potential here? K dq by this distance, that will be root over of r square plus x square. What expression did you use? You used the expression for potential due to a ring. Till here, is it clear?
Yes, sir.
K, I'll put K as 1 by 4 pi epsilon naught sigma into area of the ring 2 pi r dr. Sigma into area of the ring 2 pi r dr root over of r square plus x. So far, so good. Yes or no? 2 pi 2 will go sigma by 2 epsilon naught r dr root over of r square plus x square. Least value of r is 0, maximum value of r is capital. Is that okay with all? So,
Yes, sir.
how will you do this integration?
By substitution.
What? क्या substitute करोगे?
R square plus X square equal to T.
R square plus x square is t square. We have done n number of those substitutions. You will be able to do this integral, right? No big deal. I will get potential as sigma by 2 epsilon naught. After substituting the limits, you will get root over of r square plus x square minus r. This is the expression for potential that you will get. Sorry, minus x. Because limits are put for small r. Limits are put for small r. This is the expression for potential. I skipped the simplification of the integration here. You will do the simplification by putting let t square be r square plus x square. 2t dt is equal to 2x. Now I want the field. Sigma by 2 epsilon naught. How do I get the field? Minus dv by dx. Minus dv by dx. I'll move by a distance of dx. Differentiate this with respect to x. 2 root over of r square plus x square to x minus 1. Obviously with a negative sign. So what will be the expression for field? Sigma by 2 epsilon naught 1 minus x by root over of r square plus x. You should have done this in gravitation also, Mayar. Using integration. I intentionally didn't do this. Now I'll show you using solid angle how do you get this value of field in a very different way. Take it down till here. You are expected to remember both these expressions along with ring, hollow sphere and solid sphere.
Done, sir.
Just a minute, sir.
Okay.
Done, sir.
Listen to this very carefully. You have taken a disk this way. You have positive charge all throughout this disk. Consider a small area ds, which will give me a d like this. Consider a small area ds, which will give me a field there. I'll take this angle as theta, this is theta, dE cos theta, dE sin. Say something.
Yes, sir.
Can I claim as this area goes around, dE sin theta components will get cancelled out?
Yes, sir.
Yes, sir.
Everybody convinced?
Yes, sir.
All I will have to do is integrate dE cos theta. dE will be k dq by small r square. Small r is this distance. Small r is this distance from here. Cos theta. This step is everybody convinced?
Yes.
kq by r square. This distance is r.
Yes, sir.
dE is k dq by r square. K sigma ds by r square cos theta. Sigma ds is dq.
Yes, sir.
1 by 4 pi epsilon naught. Sigma ds cos theta by r square. Can you recognize what is ds cos theta by r square?
D omega.
D omega the solid angle. This is
Yes,
ds
sir.
cos theta by r square will be the solid angle.
Yes.
If I integrate the complete solid angle, I'll get the solid angle here, this solid angle.
Yes, sir.
If I integrate whole of this solid angle, I should get the total solid angle subtended by the disk. Sigma by 4 pi epsilon naught into this solid angle, I'll call it omega.
Yes, sir.
Sigma by 4 pi epsilon naught 2 pi into 1 minus cos theta. Substitute cos theta or use different symbol. Here you use theta, right? Call this alpha. Call this alpha. Don't use the same symbols. What is cos alpha? Sigma by 2 epsilon naught 1 minus x by root over of r square plus x square. Isn't this the answer that you are expecting?
Yes, sir.
Yes.
You took a small area, found out the field, all d sin theta will cancel out, all d cos theta will add up. You didn't do the integration actually. You took ds cos theta by r square at this solid angle. Integration of that solid angle will give you the total solid angle subtended by this. And that is 2 pi into 1 minus cos alpha. Yes, it is a brilliant solution. Hence, I keep this disk procedure pending till here so that I do both the procedures simultaneously. 1997 JEE, they asked a very good question based on this, which I will solve in the next class, and then we will go ahead. Take it down till here. The expression that you'll have to remember: field and potential due to point charge, due to a ring, infinite long wire ka field, semi-infinite long wire ka field, disk, hollow sphere, solid sphere. For these, the expressions must be remembered.
Done, sir.
Homework: based on Gauss law, there is a third electrostatic. I have given you 2 assignments, right?
Yes, sir.
Yes, sir.
थर्ड असाइनमेंट एक और लेक्चर के बाद आएगा यार। हाँ, एक और लेक्चर, the next shielding. I'll have to deal with shielding and then you will have homework. When can we have a doubt lecture for the 2 assignment sheets of electrostatics?
So even HCV, right?
HCV, right? Even HCV. Not today, yaar.
So next week.
नेक्स्ट वीक कब बता दो आप मुझे, याद दिला देना। उस दिन शाम को 4 बजे रख दी।
Okay, sir.
इस दिन आप लोगों के लिए ठीक होगा। Harshit is typing HCV electrostatics was fully discussed.
Yes, sir. Yes, sir. It was.
तो फिर से HCV क्यों? तो electrostatics का 2 assignments दिया हुआ है, that should be discussed, right?
Yes, sir. Spark by. And sir, I think SHM HCV is left some part.
हाँ, then both of them.
Gravitation booklet.
हाँ, gravitation booklet.
हो गया ना? So I think.
So exercise 5 बाकी है बस.
Okay.
Yeah.
Well, keep me informed next week. Other than the doubt lecture, which phase gives, we'll keep one doubt lecture extra and finish it off. Okay. By the way,
Yes,
today is
sir.
Thursday or Friday?
Thursday.
Okay. See you people in the next class. No new homework. Please go through your class notes in detail for today.
Okay. Thank you, sir.
Thank you. Bye and good day.